Hello, this is Anjani, your maths mentor. Now I'm going to start NCERT book chapter 1 rational number. Before we start, we will learn about the sum number. First of all, you all know the natural number which start from 1, 2, 3, 4 and dot dot up to infinity. And the second is a whole number which start from 1, 2, 3 up to infinity. If we tell about the integers, a number which has a negative number and a positive number and a zero is called a integers. If I want to show you these in a number line, show how it will see. I show you a natural number. If this position is a 0, then natural number is shown 1, 2 up to infinity. These are natural number. If we add a 0 in a natural number, it become whole number. If we add in this whole number negative number in a whole number, then we get integers. Means a natural number is a whole number and a whole number is a integers. Okay, suppose we have a number line from a 0 to 1 and I have to divide it in two parts. Then how would you divide it? It will be 1 by 2. In a general form, this is called P by Q form. P in a numerator, Q in a denominator, and Q not equal to 0. And here P and Q are integers, means ki negative value also will be count in a rational number and positive value also counts in a rational number. These P by Q form is called rational number. What? Rational number. So our chapter name is rational number. A number which is in a form of P by Q, where P and Q are integers and Q not equal to 0, because if Q is equal to 0, then this form will be what? Infinity form, means undefined. That's why in a rational number Q not equal to 0. I give you some examples of a rational number. -1 by 2, 5 by 2, 0 by 0 form is also a rational number form. 6 is also example of rational number, because here in a denominator we count 1. Okay, these are some examples of natural number. Now we will discuss about the properties of rational number. First property is closure property. So we will check on all the operation, on addition, on subtraction, on multiplication and division. First we will check on addition. Closure properties of rational number in addition. Let's take any two number which is in a rational form. I am taking 5 by 2 and 7 by 2. Okay, and add both the number. What you will get? You will get denominator 2 and 7, 5, 12. If we will cut it, then we will get 6. This is in a rational form. 6 is a rational number. Yes, it is a rational number. Means ki closure properties satisfy for the addition. Now second is subtraction. We will check on subtraction. It is satisfy for subtraction or not. Let we take same example with the subtraction. 5 by 2 minus 7 by 2. What we will get? We will get minus 2 by 2. That means we get minus 1. Is it a rational number? Yes, it is a rational number. Means closure property satisfy for the subtraction operation. Next we will take the multiplication. Let any two number, suppose I am taking same number 5 by 2 multiply 7 by 2. What we will get? We will get 30 by 5 by 4. Is it a rational number? Is it in a p by q form or q not equal to 0? Yes, it is a rational number. So closure property for multiplication is satisfied here. Next is a check on a division. I am taking the same example 5 by 2 divided by 7 by 2. What we will get? As it is, we will write 5 by 2 and reciprocal of 7 by 2. That means 2 by 7, which is equal to 10 by 14. Is it a rational number? Yes, it is a rational number. So closure property satisfy for all the operation addition, multiplication, subtraction and division. Okay, getting my point? Properties. In a properties, rational number satisfy closure property addition, subtraction and multiplication. Now let's go to the second properties, which is commutative law. So we will check the commutative law which satisfy the rational number in addition or not. First we will check for addition. I am taking the same number which is rational number and going to add it. 5 by 2 plus 7 by 2, we have 12 by 2, which means 6. If I reverse this number, means 7 by 2 plus 5 by 2, I reverse 7 by 2 and plus 5 by 2. What I will get? I will get the same number. Means if I cut it, then I will get 6. In a general form of commutative law, a plus b is equal to b plus a. This is called the commutative law. By example, I shown here. If 5 by 2 plus 7 by 2 is added, then we get 6. If I reverse this number, so 7 by 2 plus 5 by 2 is also 6. So commutative law of rational number for addition satisfy. Now we will take for the subtraction. I am going to take the same number and going to subtract it. If I subtract this number, then I will get minus 2 by 2, which is minus 1. If I reverse this number, means 7 by 2 minus 5 by 2, what I will get? I will get 2 by 2, which means 1. Is it minus 1 is equal to 1? No, it's not equal. That means commutative law for subtraction is not satisfied. Means not satisfy. What? Commutative law is not satisfied for the subtraction. Now coming to the multiplication. In a general form, I can write it a minus b is not equal to b minus a. Okay, now come to the next multiplication. For multiplication, I am going to take the same number. If I multiply this number with this number, I will get 35 by 4. If I reverse this number, 7 by 2 multiply 5 by 2, what I will get? I will get the same number. Means in a general form, a into b is equal to b into a. It means that commutative law for multiplication is satisfied. Okay, now we will check for the division. If I'm going to take the same example and 5 by 2 divided by 7 by 2, it will get 5 by 2. Reciprocal of 7 by 2 is what? 2 by 7. Means I multiply, then I will get 10 by 14. Now reverse this number, means 7 by 2 divided by 5 by 2. What will you get? You will get 7 by 2 into reciprocal of 5 by 2 is 2 by 5, which means 14 by 10. Is it equal both? No, it's not equal. So in a general form, A divided by B is not equal to B by A. Means for the rational number, commutative law of division is not satisfied. Not satisfied. Okay. Now we will check for the associative law is satisfied in addition, subtraction or multiplication or division or not. So I am going to take any example. 5 by 2 plus 7 by 2 plus 3 by 2. Okay, 5 by 2 plus 7 by 2 plus, if I added this, I will get what? 10 by 2, which is equal to 15 by 2. Now if I am going to take 5 by 2 plus 7 by 2 in a bracket or add 3 by 2, what I will get? I will get 12 by 2 plus 3 by 2, which is equal to 15 by 2. Is it both are same? Yes, it's a same. In a general form, we write A plus B plus C is equal to A plus B plus C. Both are equal. Then we can say that the associative law of addition is satisfied for the rational number. Now we will take for the subtraction. I am going to take the same example. 5 by 2 minus 7 by 2 minus 3 by 2. What I will get? I will get 5 by 2 minus 4 by 2. If I cut it, I will get 2. 5 by 2 minus 2, which is equal to 3 by 2. Now take the 5 by 2 and 7 by 2 is together and minus 3 by 2. Okay, what I will get? I will get minus 2 by 2. If I cut it, I will get minus 1 minus 3 by 2. This is equal to minus 5 by 2. Is it 3 by 2 is equal to minus by 2? No, it's not equal. That means associative law of rational number not satisfied for the subtraction. Okay, not satisfied for the subtraction. Now come to the multiplication. I'm going to take the same number and 5 by 2 into 7 by 2 into 3 by 2. I will get 5 by 2 into 7 3s are 21 by 4. If I multiply 21 into 5, I will get 105 divided by 8. Now I will take 5 by 2 and 7 by 2 together and 3 by 2. What I will get? I will get 35 by 4 into 3 by 2, which is equal to 105 by 8. It is satisfied for multiplication. How? Because both are equal. Now in a general form, we write A alone and BC together, which is equal to AB together and C alone. Okay, this satisfied for the multiplication. Now come to the division. If I am going to take the same example, 5 by 2 is alone and 7 by 2 is together, what I will get? 5 by 2 division, and this will be a reciprocal, then 5 by 2 into 2 by 3, which means I will get 5 by 2 division 7 by 3. Again it will be reciprocal, then 3 by 7. What I will get? 15 by 14. Now I'm going to take 5 by 2 and 7 by 2 together and 3 by 2 alone. Okay, what I will get 5 by 2, reciprocal of 7 by 2 is 2 by 7. If I cut it, and division of 3 by 2, which is equal to 5 by 7 divided by 3 by 2, which is equal to the 5 by 7, and reciprocal of 3 by 2 is 2 by 3. What I will get 10 by 21. Is it 15 by 14 or 10 by 21 is equal? No. That means associative law of a rational number for division is not satisfied. Okay, distributive law, under multiplication over the addition, we will multiply a with the b, then we get ab, plus sign is there, we put the plus sign, and a plus a into c. Okay, and distributive law is also satisfied for the subtraction properties. Okay, mean a b, we will write a b minus sign is here, a c. Question of exercise 1.1 is using appropriate properties find this. Okay, so I will going to change something. Now can I write this equation in this form? Yes, I can write up. Now I am going to use the distributive law. I applied here distributive law. As a distributive law, we know that multiplication over addition, what we have a, I multiply a with a b plus a with a c, so I can write ab plus ac in the form of this. So I do the same thing with this. I took 3 by 5 as a common like a, and rest I leave as it is. Now solve this bracket. LCM of 3 or 6 is 6, so I am writing minus 2 as it is. And in how many counts you will get 6 in a table of 3, you will tell that 2 times, so I am writing here 2, minus as it is, 1 as it is. In how many times you will get 6, so you will tell 1 times. Okay, 5 by 2 as it is. Now after solving this, I have minus 4 minus 1 divided by 6, or 5 by 2 as it is. Now I'm going to solve it, and I get minus 5 divided by 6. Now can you cut 3 by 6? Yes, you can cut in a 2 times, and a 5 with a 5 in a 1 times. What you will get minus 1, nothing else, and in a denominator you will get, and write 5 by 2 as it is. Now I am going to take LCM of 2, or 2 is 2. 2 ones are 2, means as it is I am writing minus 1 into 2 ones are 2, means multiplication with a 1, plus 2 ones are 2, 5 ones are 5. Okay, now after solving this, minus 1 is minus 1, plus 5 into 5, 1 is 5, and divided by 2. After solving this, I will get 5 minus 1 is 4, and I will take positive signs of bigger number. Which is bigger? 5 is bigger, so here will be 2. Now 4 is divided by 2, what you will get? You will get 2. So here is our answer, 2 is our answer. Okay, to find the common number, we have 2 by 5 and 2 by 5 is common. Can we write this equation in this form? I am taking the 2 by 5 in on this side. So here 2 by 5 and 2 by 5 is a common. If I will taking 2 by 5 is I will take 2 by 5 is a common, then what we have? I have minus 3 by 7 plus 1 by 14, is it? And we have left minus 1 by 6 and 3 by 2. Okay, now I'm going to solve whatever number we have in bracket. I'm taking the LCM of 14 and 7 is, what will be the LCM? LCM of 14 and 7 is 14. 7 1 ja 7, 7 2 ja 14. How many times you get 14? 2 times. I write minus 3 as it is, and I get 14 in a 2 times, so I will write here 2 plus 14 1 ja 14, means 1 into 1. Okay, now let's solve this. 3 1 ja 3, 6 2 ja 12. Okay, now try to solve it. 3 2 ja 6, minus 8 is it, plus 1 1 ja 1. What I get? I get minus 6 plus 1 divided by 14, and another side is minus 3 by 2. Now if I solve this, then I get minus 5 by 14 minus 3 by 12. Now can you cancel this number, minus 5 and 5? What I will get? I will get minus 1. 1 times I cancel, so I have 2 by 14, minus is here, and minus 3 by 14. What will be the LCM? Can I cancel one more time? So 1 1 ja 2, 1 ja 2, 7 2 ja 14, means I have 1 by 7 minus, if I cancel this, 3 1 ja 3, 3 4 ja 12, then I have minus 1 by 4. If I cross multiply this, so I will get minus 4 and minus 7 divided by 7 to the how much? 14. If I solve this, then I will get minus 11 by 28. This is our answer. Okay.